So without further ado, because Peter has much more to say than me today, and maybe it's also not only today, but let's welcome Peter. Peter, you probably can share your screen and yeah, exactly. So Peter, the floor is yours. And dear colleagues, participants, please ask your question, even on the fly, in the chat box. Thank you again, Peter, for being with us today, and the floor is yours. Thank you again.
Great. So thanks very much, Christophe, and hello everyone, and welcome. And it's great to see so many of you here. So Christophe gave me a fairly open agenda about what I'd like to talk about, and having a little bit of a look at some of the other things which were being covered in your course. I thought one of the things which I'm got a particular interest in, and which I think fits quite well with this concept of advanced data visualization, is sometimes bringing it back to things which are a little bit simpler and a little bit more aimed at audiences that are not the most sophisticated in terms of statistical literacy. And that's why I came up with this idea of let's talk about actually polishing graphics, because you can have a simple graphic, but when it's to actually have impact, it's got to be well designed, it's got to be polished. There's an enormous amount of craft that's going into that. And I realized that when I've been involved in this sort of work of producing graphics for decision makers, for ministers, for publication and for others, it's people who haven't been involved in that often underestimate the amount of craft and the work and the iteration and the thousands of different versions you go through with graphics before you get that final one you want to put in front of the minister or put out for publication. And so that's really what I'm going to be talking about today. I'm going to be sort of dividing my talk up into three sort of sections. I'm going to talk a little bit about the different purposes of graphics, and how different graphics for different purposes leads to different types of graphics before we focus in on the type I'm going to be talking about today. Then I'm going to have a brief discussion of, well, what is it that makes graphics excellent? What does excellence mean when we say we've got a beautiful statistical graphic, it works, it achieves the impact we want, it helps influence decision making, which is really the purpose of so many of the graphics which we're going to be talking about. And then finally, I'm actually going to go through 5 examples that most of them are either real life ones I've used or very closely modeled on real life examples from various roles that I've had, and just show the decision making that goes through some of the iterations in making those graphics. And as Christophe says, we'll have time for questions at the end. Questions are all going to be done via the chat. I will obviously answer them orally, but you'll have to ask them in the chat. So feel free to start putting them in as you go, and you know, even I might address them as we go if they're particularly relevant for points. Otherwise, we'll have time at the end where I can address them, and Christophe might facilitate a bit. So to start with the different purposes of graphics, I wanted to put this in because this is a course about advanced data visualization and the SDGs and official statistics. I wanted to put this in the context of the generic statistical business process model, or the GSBPM, which is a big thing we're getting right behind at the Pacific community as a way just to divide up the different parts of the statistical process, whether you're specifying the needs, designing your surveys or admin data collections, building the things, whether it's building a survey instrument or building a database, the collection, the processing of the data, which is things like weighting and machine outliers, analyzing, and of course disseminating. Each one of these stages in the process of actually producing and using official statistics is going to call upon statistical graphics in a slightly different way. And I like to think of these as having 3 fundamental different purposes for a graphic. It can be exploratory. So you've got your exploratory data analysis process where you've got a new data set, you're just having a look at it, you want to see what the distribution is, what's the middle, how does this compare to the other, and you produce hundreds, maybe thousands of charts with a new data set as just your familiarization of that data. And these graphics you're producing here are very opposite of polished. which is like the topic we're talking about here. And it's a big mistake to, when you're producing these, to be worried about, oh, this one's ugly, or this is really hard to understand. And I've often got these when you're on a team where you work with people who aren't so used to statistics. You're producing these complicated charts, which are just as your exploration. Maybe some of them are specialist charts like box plots or mosaic plots or something. And people say, oh my God, we can never show the client this, or we could never show the minister that. And I would say, don't worry, it'll change a lot. It'll probably be a simple bar chart by the time it gets to the minister. Sometimes we're having these sophisticated plots at the beginning stage. Then in the middle of the process, you've got this analysis, and in particular the diagnosis. And this is particularly important when you're doing any kind of relatively sophisticated statistical modeling, that you really build in your graphical production as part of the analytical process, and particularly part of the diagnosis of problems. So if you, for instance, got a linear regression model and you've got various assumptions about the way the residuals are shaped or the distributions and so on, it's really important to be using graphics as the easiest way to see, are those patterns being met? Are we seeing those assumptions being followed? Are we seeing something wrong, like curvature in the line that should be straight? And again, these are things you're never going to show to a client, you're never going to show to a minister or publish unless you're in a scientific journal, but it's a critical role for graphics. And finally, you've got presentation graphics, and that's more what I'm talking about today. And often you might find you've produced hundreds or thousands of graphics in the first couple of categories, and you pick a couple of them and say, actually, this is interesting, or this one really seems to show the result or the trend which we're trying to get across here. I'm going to go with that one, and we're going to polish that up into something which we can actually give to a client. And so I wanted to start by being really clear on these different purposes of graphics, because it makes so much difference to the effort we put into them. Think about the audience and think about the particular purpose of the graphic. When you come to presentation, you've got a fundamentally different idea in your head about what it is you're trying to do with the graphic. You're most likely trying to say, we want people to see a trend really clearly. We want them to see a comparison really clearly. And we want often a wide audience to understand it straight away. We don't want people to look at this and think, oh my God, I need a PhD just to understand this. It's usually got to be something that's going to hit you between the eyes with the impact of the thing. And just as some examples of the power of graphics at the different moments here and illustrating some of this, I'm going to start with thinking about what are graphics good at. And we're starting up here. I've got an example of something where just looking at a table of numbers is very hard. Some of you may well recognize the name of this data set, the Anscombe data set. This is it on the page. But there's nothing remarkable, I think you had to be very, very familiar with numbers to pick out unusual trends here. When you plot these 8 columns of numbers as actual graphics, you get this. So these are 4 different data sets. Each one has got exactly the same line of best fit going through the data points, but each data set has that line of best fit in a radically different ways. Like data set 2, clearly the real trend is a curved one, even though the straight line goes through it. Data set 3, there's a single outlier, which is pulling the line up a bit. In data set 4, you've got a single outlier, which is totally dictating the line. And data set 1 is probably more what we're actually looking for when we're fitting this sort of the model that this line implies. The reason for showing this is just illustrating that, particularly when you're at one of those first 2 purposes I'm talking about for a graphic, an exploratory purpose or doing diagnosis in your analysis, this sort of chart is critical because you just can see things in the visual that you just couldn't see in the table of numbers. The second critical purpose, and one which I know Christoph, I'm sure, has talked about, and as he said, I'm passionate about the good use of maps. It's just putting data in its sort of spatial relation. And here I've got like another very famous data set. This is from a cholera outbreak in London in the 19th century. I'm sure many of you have heard the story here about how critical to understanding what was causing the cholera outbreak was just taking the coordinates of where the houses were that people were getting sick and plotting them and using this to see that actually they're all centered around a few streets in the middle here. And they used this to help identify that there was one particular water pump that was basically responsible for a lot of the cholera problems. So this was a very, very simple exploratory or analytical use of graphics that just like led to a very powerful conclusion quite early on. But it's also a nice example of if you then wanted to go and persuade people of that, you might take what doubtless originally started as a bunch of crosses on a map of the streets of London, turn it to something that was quite polished that you're going to show to decision makers and actually say, you see the impact of this, see the way all of these red dots are all around this one very small part of London. Maybe there's something about that part of London that we need to investigate. And of course, that was exactly what they did do when they removed the pump handle from that water pump. And that had an important, possibly even decisive impact on reducing the cholera outbreak in London at that time. Then there's examples of using your data during analysis. And here's an example here. This is a scatter plot matrix with density charts down the diagonal and correlations on the top right. This is the sort of thing that I would often do when I've got like a multivariate data set. In this case, it's coming from the New Zealand census. Each dot here is an area unit, which is a very small collection of houses in the New Zealand census. And it's looking at things such as the proportion of households that have got multiple people in it, how many bedrooms are there, what's the median rent they're paying, and just trying to show in one graphic the relationship between all of these sorts of variables. The reason for showing this isn't because I think it's a great polished graphic. It's precisely the opposite. I'm showing this because it's an example of the sort of graphic that I would produce hundreds of during an analytical process, during that analytical workflow, and if you like, during that analysis column in the generic statistical business process model, that helps me get a feel for the data, understand things, diagnose my statistical models as I'm fitting them, and get ready all this in my head for thinking of maybe something here is going to be the hint about the graphic we are actually going to show. Like you might take just one of these little facets in this plot and say, this is the one we're going to put in front of the minister. And getting towards the presentation stage, so more of what I'm sort of talking about. Here I've got an example of a graphic where I am actually using a statistical graphic for presentation in a more polished way, trying to convey the results. The results which have been conveyed here are results from a very sophisticated statistical modeling process. The chart we saw previously was a small step along the way to that. Eventually it involved fitting a complex multivariable regression model to this data, basically looking for what census characteristics are most related to the median income in a particular area. And this chart is showing the simplified results of that. And so basically what it's showing is that the areas that have got a lot of people on student allowance have got low incomes. The areas for a lot of people with doctorates or a lot of people who are full-time employed have got the higher incomes. And this is sort of in the presence of all the other factors. So it's controlling for all of these different things. So for example, it's saying even after you control for the number of doctorates in an area, the number of people who've got full-time employed still helps you predict the higher income in that particular area. So this obviously isn't a substantive issue we're going to go into today, except just to present that this is my preferred way of presenting the results from this sort of statistical modeling, because it's got immediate impact. You can immediately look at these things and see roughly what it's saying. It's also doing one of the things I understand Christoph's been talking about presenting uncertainty there, because the lengths of each of these segments is an indication of the uncertainty of the impact on each of these things. So that long segment for doctorate means we're less certain about the impact of doctorate than we are on the impact of having lots of employed people in the area. And it's doing a whole bunch of these things quite nicely, representing the sophisticated model in a way that even if people will struggle to understand the statistical model, they can at least look at this and say, oh, gee, having lots of people with doctorates is more important than having lots of people who are working in financial services. That's interesting. And indeed, it is interesting. Bearing in mind that the alternative to this is like the more traditional presentation of regression results, which is a table that looks like this. And until quite recently, this is the way that economic journals and so on would basically insist on these results being presented with a column of the estimates, column of standard errors, t-values, and p-values. This is exactly the same results as what was in the previous graphic, but I defy you. It takes quite a bit of complex looking at this, and obviously it goes a lot further down off the slide as well to really get to see some of these comparisons which were blindingly obvious before, such as that areas with lots of doctorates are rich and areas with lots of people in student allowance are poor. You got to go through, look at the signs and all that sort of stuff to get to that. So that's a presentation of results. Taking a step back about, well, what's some other things we can do when we're into the presentation stage? One of the things that I like to do thinking about a statistical graphic is using it to actually illustrate a concept. And that's what this animation on the screen is doing here. It's quite a simple graphic. It's just representing two variables, a very straightforward relationship between the two. Each one of the grey points is from the actual real population, and I think these were real data points. And what I'm simulating here with the red points is, imagine from that real population, you sample just 20 people and you measure their value of your X, you measure their value of Y, and you fit a regression line through it. Because you've only got 20 people, you've got uncertainty, sampling uncertainty. And what this animation is doing is illustrating every time you pick sample of 20, you get a slightly different bunch of points, of course, and you get a slightly different regression line through it. And I find this very useful for people who struggle with more abstract concepts of talking about you've got confidence intervals and so on for your lines. Say, well, just imagine we could have done this same exercise and got a whole different other better bunch of 20 people. Let's simulate that and you'll see how the line varies, and on average, of course, it's roughly right. It's roughly where the grey line is for the population, but sometimes it's much steeper, sometimes it's less steep. Very occasionally you're really unlucky and it's pointing in completely the wrong direction. And I find this a very useful thing for teaching or for explaining to people about why we need to be careful about small samples. And I think my second last example of this sort of thing is when we can use interactive graphics to help people play around with what otherwise might be complicated results. So for example, from a cost benefit analysis, or in this case, from a model which was predicting the way people are going to vote in a general election. Again, we can present, tables and regression results and so on, but people really like to have something like this where you can say, well, let's just look at your predicted chance where you're going to vote. So, and in New Zealand, they've got a fairly complicated sort of system where you vote for proportional representation for parties, but you still get to choose a particular party that you want. I fit a model based on individual level data about who people are going to vote for, based on things like, well, do you identify as working class? If I put it in here, you can see, well, what's the impact on any of these things? So I can imagine a hypothetical person who identifies as working class, doesn't have any qualifications, and is, say, in a lower income household. And we can see that they're most likely to be voting Labour. Whereas if we change them, say, well, what if someone's just like that, but they've got a university education, we see the chance of voting Greens has gone up quite a bit. And this is a way that really helps people explore what otherwise is a almost impossibly complex collection of interactions and multiple variables pointing into things. And this is something that we found quite effective when I was working in consultancy. We could do this with a cost benefit analysis or something like that, where people wanted to play around, pull the levers, to see, or what if the bridge costs twice as much as we thought, or what if only half people use it? Let them play with the sliders themselves and see the impact on the net rate of return and so on. And so this is an example of a graphic which can be very effective for presenting results and actually letting the users engage with results in a way that otherwise just isn't possible. And the final thing I want to mention is like ways of simplifying results. And so in this case, we're taking like average GDP growth and showing it in a choropleth map of New Zealand, or just getting people's attention. And this animation, which is on the screen here, was something we produced when I was working in tourism statistics in New Zealand. We had this flash new data set of regional tourism estimates based on credit card data and calibrated to the national accounts and so on. And we just wanted ways to, as I say, grab people's attention, say, look at this exciting new thing we could do. And we realized that one of the things we could do that was before never possible was not only do we have much better regional estimation of where it's been spent, we could actually do it by the month of the year as well. So we made this animation show not only that actually the big bulk of tourism spend is in the Auckland area, which was not necessarily visually obvious to people until we made this chart, but also that you can see the way that it changes over time. I'll restart the animation in the season. So in June, July, which is the winter season for New Zealand, the tourists go right down, well, because it's cold and miserable. In December, January, February, it's summer holidays in Australia, where a lot of the tourists are coming from, and New Zealand's weather is nicest, and you see the big tourism boom happening there. And if you look closely enough, you will actually also see in the winter months there's a little bit of a sub boom in the South Island, where some of the ski areas are. Now, this isn't a great graphic for really understanding that seasonality. Much better would be a more traditional line chart or collection of line charts or something like that. And so this comes right back to that thing I started with, the different purposes of graphics for different audiences and the different type of graphic you want to use. If I wanted a graphic that was going to help me understand seasonality, I would probably be drawing a whole bunch of line charts and looking for the dips and the bumps and that. If I want a graphic that's going to grab people's attention in the background of presenting a new data set to people, I might go with a fancy 3D animation. And this is this animation was made in about 2016, by the way. They're a lot easier and a lot smoother to make these days than we could do then. So yeah, we can bear that in mind as the technology has gotten better and it's more able to do some of these things yet people are still very impressed when we do them. Okay. Moving on to the second thing I want to talk about. Well, what is it that makes up graphic excellence anyway? I've got these 4 basic principles, which I've adapted from the famous writer on this stuff, Tufte. I think that excellent graphics are those which are really well designed, and they combine the substance, good statistics, and good graphic design, frankly. So there's an aesthetic element of it. Secondly, they've got complex ideas which they communicate with clarity, precision, and efficiency. Part of that efficiency has got the greatest number of ideas in the shortest time with the least ink in the smallest space. That really makes the impact, that draws the eyes directly to the thing you're trying to get people about. And finally, it's essential that these sorts of graphics are actually telling the truth, that we not do anything that's misleading. So some specifics, really concrete things that help you meet that. One is that a really good graphic should be comparative, should be helping you compare one group with another group. It should be multivariate. It's like it's a waste of the power of graphics to do it with just one single dimension. They should be trying to reveal interactions. That's really part of that comparison, the multivariate thing. It's like interactions are one thing that graphics can show, the interaction of one variable as it changes the time another variable is changing. That's the sort of thing the eye can pick out of a graphic that is almost impossible to relate in a table or even you even discuss in your statistical model results and so on. And finally, almost a more like sort of aesthetic point, you want nearly all of the ink on the page or the pixels on the screen to be directly showing data, and you want things which are not that to be as much in the background as possible. So what that means, just some sort of quick examples before I go into the polishing, is that if you've got something like this, which is quite a nice, decent graphic showing the results of an experiment, comparing controls and trials. But if you say, I want to really focus the eye of people on the results and nothing else, I would probably go with a graphic that looks more like this instead. Nearly everything's gone into the background or been removed altogether. I've got the emphasis just on the numbers and on the slopes and seeing the before and after. We can see that the control is on average, they're a bit flat, whereas with the trial before and after, it's very clear that they've gone they're going downhill. So whatever it is the intervention was between the before and after, you see that for the trial cases, it's gone downwards. For the control, it hasn't. That's visual impact. Nearly all the ink on the page is directly showing data. It's multivariate and it's doing comparisons. It's doing all of that for you. Second example, here's a quite good chart from real income survey microdata, but it's just one dimensional. It can be better if it's been used for comparison, if it's multivariable. So for example, if we can use it to say, not just, well, here's the rough shape of the distribution of incomes in New Zealand, but let's compare that for people who've got a bachelor's degree, people who've got no qualification and something in between. So we're using the power of graphics to make it multivariate and comparisons. Secondly, with the same data, well, we've got two variables here and we're seeing a relationship between the hours people are working and their income. It might be better if we made it more multivariate so you can see relationship, the interaction between your occupation and the hours working and what that does. Now, of course, whether this is better or not does depend a bit on the audience. And I'm putting this out there as as making the case for thinking about complex graphics that present interactions and multivariate situations that you can't possibly do in other cases. This is where the power of graphics comes into its own. Doesn't mean that this is the right graphic for your audience. This is where we need to think about, okay, when we polish a graphic, what are we going to think about? And this is going to take me into my 5 more detailed examples where I want to talk about the actual polishing process. So just before I go into the first of those, I want to talk about some research that's been done by Cleveland. I'm looking at, I've got the book on the shelf over there. I was just checking it, indeed Cleveland, who did this research, basically looking at how people perceive quantities. And the thing that they're best at is the position on the screen. And it's possible Christoph's talked about some of this stuff. And so like on a X and Y axis, you draw a dot. People are very good at comparing that and converting that in their head into a quantity. Second best thing is like a length, the length of a segment of a bar, something like that. After position and length, you get things that people aren't so good at. They're not very good at judging areas, even worse at judging volumes. Slopes, very poor, and like color, very, very difficult for people to really use color to convert into a quantity. Doesn't mean you shouldn't use color for a quantity. It's just don't expect people to be able to reverse the mapping from the color back to a number in the way they can by reading across the X or the Y axis in the scatter plot. So what does that mean for some common sorts of charts we would use? So my first example I'm going to have here is some very common data about that you'll often see in survey data. So it's not the sort of survey you'd see in the SDGs, but it's very similar data to some things that you do get in any survey and official statistics, where people have got a bunch of possible responses. They're asked, how often do you read these different types of books? And they gave an answer from never or almost never through to several times a week. And this chart that's on the screen is a perfectly decent chart. And this is the most common chart which you will see with this. Market research firms get paid a lot of money to do this. They will produce a chart that looks like that. And you can't ask for your money back. It's decent. It's telling the truth. It's okay. But I think we can do better. So how can we do better? One of the first things which I do is flip it on its side so that you can actually much easier read the things down the vertical scale. And it doesn't make too much difference on this one, but in some other cases you'll see that it's a very powerful thing to do, to put your categorical variables on the vertical axis for any kind of bar chart. Often makes it much easier reading. Second thing is I'm going to use sequential colors. So if you look at these colors here, these are basically random colors. Goes orange, purple, green, and blue. There's nothing that helps you really see that which one is several times a week and which one is virtually never. If I actually use the intensity of color to indicate, in this case, the darker the green is, the more times people are reading this book, it's immediately more apparent at a glance what is going on here. So I think this is making a really quite powerful big change here. But The other thing you can do with this sort of data, so rather than having a univariate sequential thing, you can use a diverging scale. Now, I think you can, to doing this, you're implicitly choosing a middle of the scale, and like whether this is the right data to do this, you know, there's a bit of a judgment call. But if you've got one of these scales where the middle is like a don't know and it's an agree and disagree on the other side, it's nearly always going to be better to use a diverging scale. For something like this, where you might argue there's a bit of a natural center at about once a month, and you're interested in, well, what are the sorts of things people read more often than once a month, things people read less often than once a month? By using a diverging scale where I've got intensity of green on the left and intensity of brown on the right, I've made that much more visually impactful again than I had the first time. And then finally, to what I think is the best picture of this sort of thing, is to actually say, well, remember, people aren't very good at judging colours. Much better is if we remember that what they're really good at picking is position on the page. And let's leverage that to produce one of these sorts of diverging, I don't even know what you call these charts, but they're the right way, in my view, to show this sort of data. You see that I've arranged the magazines to non-fiction books in the sequence from the most read to the least read, but most importantly, I've done it so that you can immediately see, even if you're completely colorblind, and like 10% of men are colorblind, but you know, even they can usually tell the difference between the brown and the green. But even if you're completely colorblind, you can see now just by the position, which everyone is quite good at reading, which ones of these are the most read and which ones are the less read. So this is my idea of like a really good graphic for this sort of data, compared to the original one, which, as I say, wasn't lying, it wasn't bad or anything, but you know, it's just not as good, it's not as impactful as this, which is making the best use of the position, the way that we judge position and convert that into a number in our head. So my second example is a little bit more sort of aesthetic. So again, I'm taking some perfectly respectable real data. In this case, it's showing economic growth rates and inflation rates for 3 countries and a whole of world comparison point. And I've started with a deliberately rather ugly aesthetic, but it's a completely respectable one. It's actually pretty similar to what used to be the default in Excel about 10 years ago. So recently, Excel's defaults have gotten a lot nicer than this, partly because people like me kept making fun of them, I think. But the, you know, 10, 15 years ago, you know, you might do a default chart and it would be what I think is pretty ugly like this. It's breaking a whole bunch of the principles I was talking about before, not least the one about wanting most of the ink to be data ink. So I'll just quickly go through my process for improving this. First thing is to just minimize the axis guides a bit. So you see in the original one, we've got all this repetition of 0, 5, 10, 15. It's unnecessary, sort of get rid of that. Second thing, just make the axis titles a little bit faded from where they were. So it's like moving them a bit into the background compared to the data. Third thing, getting rid of these horrible borders around the outside, and then getting rid of some of the other boxes around the charts and around the legend. They're not doing anything, but they're just getting the focus of your eyes. Then this is an important one, moving the guidelines to really conceptually at the back. And when you've got a dark coloured plotting area, it's nearly always best for your guidelines to be really pale, like white or very pale grey, to make basically the data stand out. So just compare the one with the black guidelines with one with the white guidelines. The data here is just showing up much better. Then I think we can make the background even further by just paling the shade of grey. So you'll start picking up a theme here. I think a lot about which shades of grey I'm going to use in my various charts. So the difference between the last two is just I've made things a bit paler to help the data stand out a bit more. Then I'm going to move it to my thematic theme. So you might see that throughout this presentation, I've been having a lot of charts with this sort of yellow background and the white lines. That's my consistent theme I'm using. We mustn't forget to use the right font. So I'm trying to use Calibri font consistently. Very important, but often forgotten. People have different typefaces in their graphics from their what the typeface in the text is. And then adding in corporate colors. So these colors here are some of the official SPC colors that we like to use. There's nothing wrong with these original ones, but it's like, if I want to get my really professional look and feel in what's eventually going to be a publication, I need to get that consistent color. And then finally, I've just gotten rid of the legend and just used direct labels instead. This basically means that your eyes don't need to move up and down to work out which one's inflation and which one's the economy, and you can go straight to it. So this is my final polished version of what was originally. It's like perfectly respectable, nothing wrong with it, wasn't lying or anything. It's just not as pretty and well designed as this one. So the principles we're talking about there, removing all the unnecessary ink, really focusing on the data and trying to get that well-designed sort of look. Third of my examples, starting with what's, I'm sure, a very common chart that a lot of you see a lot of. This is like a really common thing you see in any kind of government statistics, a bar chart showing two variables at once as a side-by-side bar chart. So this is one where it's quite hard to read all those regions at the bottom. The first thing you can do is get rid of the region, which was redundant because there's Auckland region, Canterbury region, Gisborne region. So like for graphic purposes, that's a waste of ink. We're going to get rid of that. Second thing I'm going to do is flip it on its side where it's much easier to read because I'm no longer having to turn my head to read these. Then I'm going to reorder them. So they were in alphabetical order. It's much more powerful in this sort of chart to order things meaningfully. But then I'm saying, okay, this is good. We've made a lot of steps here, but I don't quite like the strobing effect. And it's still quite hard for me to see the relationship between, in this case, the proportion of people working in agriculture, forestry and fishing and the proportion who are smoking. So I'm wondering, should I actually be using a completely different chart altogether? This is where I think about a better geom, if you like, that grammar of graphics terminology, which I don't have time to go into, you can search for that, might be to actually map this to the variables to X and Y and present them with the point geom, which of course we need labels to say which point is which point. But depending on the purpose of what we've got here, this sort of graphic is much better at seeing the relationship between the number of smokers you've got and the people working in agricultural, forestry and fishing. There's a few things we need to do to make this aesthetically better. One is it's probably nice to actually show that regression line, help the reader see that. And you might see that I've improved the labeling a bit. And finally, remembering that good graphics are multivariate and focus on comparison, I'm going to add in another variable, say, well, which of these places are in the South Island, which are in the North Island, which is the simple breakdown of the geography in New Zealand. And that immediately, particularly for someone who doesn't automatically know that Otago and Tasman are in the South Island, adds another dimension where you can see some interesting things there, such as that, okay, the low smoking but high agricultural areas seem to be disproportionately in the South Island. These are the things which might be of interest if you're concerned about the relationship between ag, forestry and fishery workers and smokers, which is a bit of a contrived question, but it's not an unnatural thing to consider. So this was an interesting journey because you remember we started with this one, we ended with something which was completely different, but it's an example of the sort of journey which I might go through as I'm polishing a graphic for an audience. And the lessons from that was, well, I like to use the position on the page because we said that's what people perceive best. Second, I wanted to make it as multivariate as possible and easy for people to make the comparisons. I added in color when I needed to make comparisons, and the particular color I used was a small number of colors just to distinguish the South Island from the North Island. And a design thing, I wanted to avoid that sort of strobing, which I don't know if anyone else saw it, but when I was looking here, it felt to me like if this ever went on television, it would cause problems for people. Right, just got two more short little examples now. I'm going to start with one of the dreaded pie charts. This is showing tourism spend. I'm sure you've heard lots of people say how bad pie charts are. I'm not a fan of them myself. This is an honest chart, but it's not a very good one for presenting these relatively 13 or 14 numbers. So stacked bar chart is already better because people, at least people could just judge the heights of each of these segments much better than trying to judge the angles, remembering that the order of way people perceive things. But position is much better. So if we separate out the bars and doing this, suddenly it's much more apparent. Australia is the biggest market. China is the second biggest. You can see a problem with those texts along the bottom though, right? So you can probably guess what I'm going to do. I'm going to flip the chart so we can read it all down there. I'm going to reorder the countries so Australia is at the top. Now the user can just read down Australia, other, China, USA, and immediately get to see something. This is now a vastly better chart. I probably prefer it to look like this because the little point at the end of these lollipops is the actual point that says how much are they each of these countries spending. And then I think, well, if I look at this, Australia to that dot, my eye has to move, I know, about 10 degrees. It's like it's 10 inches on my screen. Why not put the Australia right close to the dot so people could read that? And then why not go the other extreme and say, well, this isn't particularly intensive in the data. We could add in something useful there, such as the percentages that each of these make up for the total. So this will be my final polished plot for that tourism spend, remembering that we started with this. So I'm going to go into my last example to make sure we've got time for a few questions. And this is about not being afraid to use statistical transformations. Now, I often I'm an R on this because these are things which can put off audiences, but used the right way, they can be really critical. And I'm just going to illustrate a data set that's really helped by annotations or transformations in two different ways. So this is the data set. This is monthly tourism arrivals to New Zealand. And this is on the raw scale. It's a nice graphic. You can see this really zigzag thing, which is this seasonality we were talking about before. You can also see the collapse with COVID right at the very end. And for many purposes, this is a great graphic. For some purposes, though, you might want to say, if I want to focus on growth rates, and if I want to see when things are growing and shrinking, even when the absolute numbers are smaller, I should take a logarithm of this, and that will get you quite a different look. And the different look thing that comes visible here is that, well, actually the growth rate, which is represented by the slope when you take the logarithms, is it grew really steadily up to the late 70s and then less fast from the 70s onwards. So that's interesting information which you wouldn't have got from here. But you need to know how to interpret logarithmic scale to draw that conclusion I just did about the growth rate. So this comes to audiences and so on. The second thing is, right, that stuff in the 1940s, that was the Second World War, that was totally not apparent at all because everything's flat. When you take the logarithms, you can see that, well, there weren't many tourists even before the war, only 1,000 a month, but the few that there were collapsed during the war. Now that may or may not be interesting. So again, it depends on the purpose of the graphic. But even better is to take this and say, instead of all this ugly zigzag, can we show the seasonally adjusted variable? So you see, I've made the original one, I've kept it, but sent it back into pale gray. I've added in the seasonally adjusted series, which is a transformation in its own right. And I've put in a few annotations to show where World War II is and so on. And this, I think, is a really nice polished graphic for a particular purpose. And the particular thing I'm illustrating there is that you might want to consider taking logarithms of your data, and you might want to consider doing things like seasonally adjusting it if that's going to help people see the trend and the line, more importantly. So that's the rough lessons from that. Don't be afraid of the statistical transformations. Do use annotations, and if you see the way that I did it, I used some subtle grey shading, subtle grey text saying World War II. You know, I'm not making a big deal of it, so the data is still very much in the foreground. There's lots of transparency in that rectangle I've drawn there. So you don't want your annotations to take away the emphasis on the data, and you use lots of subtlety and colour to do that. So that's the end of my talk, really. The final word I just want to leave you with was what we were saying before, these really practical things about what it takes to meet those principles we were saying. And so that's like make your data graphics comparative, so you're helping people compare one thing to the other. to do that, help make them multivariate and help them reveal interactions. So if you're thinking comparative, multivariate, reveal interactions, you're on the starting point for what's going to be a really powerful use of the power of graphics in a way I can't use a table, I can't use text. Then for nearly all the ink being data ink, so have your annotations, have your guidelines, have your axes and your labels, but make them pale gray, push them into the back, and all the emphasis on the data. And that's that last point. All the attention on the data and everything on the story. So this presentation was actually all written in R, and it uses the markup language called Quarto, which lets you combine text with graphics and code really quite well. You see it works nicely with the styling for my organization. The SPC has got my logo and everything in there, and done all with colors, which is an important thing always to remember, right? Corporate logos are important and corporate colors are important, and all the source code is available there on GitHub. And that was really what I wanted to talk to you about. So I'm yeah, excited to take any questions in the next 5-10 minutes or so.
Thank you so much, Peter. That was really excellent, and I think it shows how much difference it makes to polish, because we emphasize quite a lot during this course the point of the reader, that we should take into account the reader point of view. And in your last example, the reader was you. You discovered this this difference in the growth or the drops during the war. So you were the first reader of your graphics. So when you polish your documents, you also discover things, which is something that is sometimes not expected. Sometimes you think you have discovered all during the analysis, and as you say, in the first steps of any analysis, you know, try to first try to explore the data set and then analyze, diagnose. But even in a polishing phase, you discover things that you never expected to see, to quote Turkey, right? So that's yeah. So that's something that I was not completely conscious about. You know, the polishing phase is also very interesting. Another thing I wanted,
sometimes you discover things in the polishing phase that you just didn't before. And one of the things that I've discovered, and I sort of hate, but it seems inevitable, is that like you get to what you feel is the end of the project, and you're producing this graphic to present it. Say, oh right, this is going to go to the Prime Minister or something, and you suddenly produce the graphic. You say, when we show it to him, he's going to ask this question, isn't he? And then you say, well, we better answer that question, or we'd better put that. He's going to say, how do we compare to the rest of the world? And then you say, oh gosh, we should have put in the rest of the world person. And you do that, and suddenly think, oh my God, that's not what I expected. And you know, then you might have to iterate and go backwards. But I think the power of that is that it's like user-driven analysis in a sense as well. And it's like, it's not over until you really present and said, how is this going to the final person who's going to read it? And only when you start empathizing with them, do you start thinking, actually, they're going to ask, like in New Zealand, the question we knew they would always ask is, how do we compare to Australia? And so it's like, you know, we've got to make sure we cover that off. And I see we've got a few questions about software.
Question, but just to follow on that, you use the term we, which is also, I think, something we should focus on, because it means that you're not the only one. You show your graphic to somebody, or you were working with somebody who may ask questions you haven't thought about, or just by presenting, sometimes you say, oh, yeah, this is when I'm presenting, I realize that there is something missing. So I think this we is super important for the process of, you know, taking into account the reader in a coding, decoding kind of scheme. Yeah.
Absolutely. And I would love to talk about that we in particular, because you said in the intro that, oh, I'm passionate about data modernization and so on. One of the big things that we've done in my past life as consultant, and then with the teams I've been managing myself, has been trying to help analytics teams think in terms of we the team. It's like producing good graphics and good analysis has to be a team effort, because you need multiple eyes, multiple people asking questions, and critically, you need other people sort of checking what you're doing. And I might use this as a segue to the questions in the chat, because I see Nacho's asked what
software.
About
softwares, or maybe I think the second question we could also interpret that as a package, is a specific package, because I'm pretty sure you will answer to the first question as well.
So the first question, the software that I use almost solely for my own purposes is the language R. So it's just the letter R, and it's open source software. It's immensely powerful for producing graphics, whether they're beautifully polished static graphics or animations or interactive. So all of those things we saw, the animations and the interactive ones, as well as the static ones, were done with R. One of the reasons that I like R is, as well as being a very, very powerful data engineering language and statistical modeling language, which were its original strengths, is the way that the visuals are built into everything that it does. And I would say it's the best single advanced tool for statistical graphics that there is out there. But one thing that's particularly good is doing it in a code environment. It's like there's a learning curve to getting used to writing code. You write little computer programs basically to produce the graphics, but it's immensely helpful in the iteration process. And so you would have seen in the presentation, I'd go through the same graphic, and I had 10 different versions of that. If you, I'm sure we'll send around the link to my presentation afterwards, and that's got a link to the source code for that. Even if you don't understand R, you'll be able to look at the code and you'll see how I've got the code for one version of the graphic, and then I add another one line to it and that changes it. Then I add another couple of lines to it and see it there. And by doing it in code, you can see all of that building up. Whereas if you do that in a graphic user interface tool like Excel, you can still produce beautiful polished things in Excel, but you're doing it by clicking and choosing this and dragging that and so on. It's very hard to reproduce. And if someone comes to you and says, exactly what do you do, you've got to remember, oh, I did this, or I did that. And whereas when it's in code, it's all there in code. Your peer reviewer will pick it up and they can see exactly what you've done and disagree on it, or they can enhance with it and so on. So that's that's the software, the language R. There's a learning curve, but it's unparalleled power once you get on top of that. I will the question from the Solomon Islands. It's interesting. We use R to produce graphics for Pacific stuff, and I've done on my blog, I've done some Pacific data visualizations showing some of the ways which we're sort of exploring that at the SPC. So that includes, for instance, an R function that makes it really easy to draw nice maps of the Pacific with data mapped to the different colors and so on. So in that sense, that's some specific thing, but that's very much, again, obviously these are just functionality that I've built in the R environment. I could talk about Pacific data an enormous amount. Pacific Data Hub is where we get a lot of data, and that's got hooks to R, Stata, Excel, and Power BI, which are all good tools.
I think there is a question about, you mentioned that the best graphic type of visualization, but some types are better, are not the best, but better. If you can say that type also is important, what types are the most important? So if I understand it well, it's somehow a question between how to stop and how you somehow, where exactly are, maybe if I rephrase that, and I'm sorry if how you judge the the biggest gap in changing. For example, at some point you change the shape of the graphic. That's a big move, right?
Yeah.
And that was a big improvement, I think. Yeah.
Yeah, I think this is where taking a user-centric view is quite important, because sometimes you'll go through a process like what I've done there, and you'll reach a point where you say, oh, I'm making this better, but better by my standards or better for me, maybe it's not better for the audience. And I think one example for that might have been, there was a chart where I had bars and then I turned them into like lollipops, so lines with little dots and so on. I think that was better, but some audiences would feel more comfortable with the bars, and some audience you might sort of stop there. And this is actually, for me, sometimes the argument that in some really restrictive cases, I will even use pie charts. I think a pie chart is never the best graphic to from a pure theoretical point of view, because people really struggle to tell the angles apart and so on. But if you've got just 3 or 4 categories and you just want the impact of, oh, isn't that slice really big compared to the others? Nearly everyone is familiar with them, and sometimes that can work. But I say it's really audience specific. And for me, that would be one where the audience isn't very sophisticated, and it's quite important for them to visualize it more or less literally as a pie and a wedge in that. And this is a way that we think will have particular impact for that audience. Even though, I would generally say it's better to break it out and turn it into a bar chart or almost anything else really. But yeah, to really answer that question of when have we gotten good enough and it's time to stop improving it, you need to think about your audience and of course like your budget and your time and so on as well.
Yeah, thank you, Peter. I think we are a little bit on that. I think it's a fascinating question, and this principle, some people say, do not harm, because sometimes you go to either maybe too simple or erasing too many things and not thinking that you can also put some annotations, for example, which I think you show that very, very wisely, that putting an annotation to say, hey, here on the wall we have something, and here, or putting the labels directly is adding ink, but this ink is super useful for the reader.
Yes.
So yeah, but the do not harm sometimes, works, because we can, and this is also related to what you say when you code. It's easy to remove one line, right? Of code. It's probably more difficult when you're not coding to know in which step you did something and how to remove. This remove to improve stuff is easy with the code.
That's right.
Yeah. So, dear colleague, if you do not have any question, or maybe you could have question while I'm presenting, I have a few announcements to make. So, Peter, if you can stay with us for maybe five minutes, I will just make my announcement, and maybe we have a few questions during that time. So, let me share again my presentation here. So, one big news for all of you is that the peer review exercise, that is the exercise where you will have to work with data and produce a graphic kind of report. You will have, to analyze data and produce some graphics. It is open already. So this exercise actually is made of 2 parts. Since you have very numerous on this course, we will do that in two sequences. First, you will have to create this graphical analysis before Monday, 24 July, 11 p.m. Japan time. I insist on the date. I will tell you in a minute why the data are super important. So you have 12 days to do that, and the data sets are quite simple. Just you have to think clearly of the rules, and that was super nice that Peter recalled the rules, Tufter rules, and all the rules of simplification, annotation, and polishing. So now you have all the tools and all the knowledge for doing that. But the second part of this peer review exercise will be to review 2 of your colleagues' work. And actually, that will be very simple and take not so much time. You will just have to answer a set of questions and say yes, no, and eventually put some comments. And to do that, there will be automatic process on the e-learning platform. You will have until the end of the course. The course finish at the end of this month, but you will have between Tuesday, 25th July, until Friday, 28th of July. It means just after everybody submits on the platform their report, just after, a few hours after, we will allocate all the reports to all of you, and you will have to review 2 reports and then grade them, and then after that, everything will be graded, and so you really will gain from this exercise also by looking at other people's reports and what they did with the same data that you had. So this is also very pedagogical to see other people's approaches, graphic, colors, whatever differences there are here. It will be quite interesting. So the deadlines are really not negotiable because we have to coordinate. We need to have all the reports before we do this peer review, before you grade all the reports, because we will randomly assign to all of you 2 reports. And you are almost 700 on the platform, so we can really not do a case-by-case study. So I hope you understand this point, that we will not be able to do a case-by-case exception for whatever reason. We will discuss that as well during next week's webinar. And all of that is explained, so I will make a special announcement tonight, and you have everything described lengthy in the activity description in the module 2. At the end of module 2, you have now something written in orange that is open now. Look at that, and you have the instruction and everything. The module 3 will be open next week. It is super nice that Peter shows some interactive tool, the interactive platform, because module 2 is on interactivity. We also talk about storytelling and what will be the question and how to polish storytelling and visual narrative is part of module 2 next week. And next week also, please note that we will have a guest. Our guest will be Ignatius Aditya Setia from BPS Indonesia. Is one of the winners of the hackathon that was organized during the Big Data Conference last year. And he also won the award of the best data visualization for his work during this hackathon. So we'll talk about his experience in creating a very complex graphic from very complex data. And I hope you will find that interesting, since we are talking about this advanced data visualization and complexity and complex type of data. That will be super interesting. And also, these graphics will be based on maps. And you have seen how complex were maps in the module 2 this week. So I wish you all an excellent week, not without thanking Peter again. Okay, so thank you, Peter, for sending the link on the chat. One comment: how if on the presentation just illustrate the graphic with the software that all of us are familiar with? Yeah, I forgot to say that, but it's written on the concept note even. This course is software agnostic. You can use whatever tool you're familiar with. We are not judging on tools. The best tool is the tool you are familiar with. So you will be able to use whatever tool you want for creating this report, definitely. What we really would love is that you follow some of the very good tricks and tips and advice from Peter, for example. That will be really nice. Do that with whatever tool you can, and you will see that with any tools you can do that. So the presentation will be uploaded as well as the recording. Let me thank again Peter for this absolutely marvelous presentation. I was super happy. I would have loved to spend more time on this, but it's a super great. Thank you so much, Peter, and see you all next time. Take care, yes. Everybody.
Thank you. Thanks for inviting me. Cheers.
Yeah, thank you so much once again. Bye-bye.